We can use enthalpy of formations to determine the standard enthalpy of change for a reaction that's not a formation reaction, because we know that the enthalpy change for a reaction is the final minus initial, or the enthalpy of the products minus the enthalpy of the reactants. So we can use the formation enthalpies of products and reactants to calculate enthalpies for some reaction that is not a formation reaction. So let's look at this one. We're going to calculate delta H0 for this equation. So we look at this and we know that delta H0 is equal to the standard enthalpy of formation of the products minus the standard enthalpy of formation of the reactants. So in order to figure this out, the first thing we do is grab our chart and we look up the enthalpy of formation for all the products and all the reactants. And I did this ahead of time. Negative 947.7, negative 1131, negative 285.9. When you're looking up water in the chart, look carefully, because water liquid and water gas are both in the charts. Make sure you get the right one. And then carbon dioxide, negative 393.5. All of these numbers have units of kilojoules per mole. Now, make sure the equation is balanced. This equation is balanced as written. If the coefficient in the balanced equation is not 1, or even if it is 1, you're going to multiply the number that you found on the chart by the number of moles, because this is kilojoules per mole. So if I have 2 moles, I have to multiply this number by 2 to get the amount of heat for this particular reaction. And now we add in the products and we subtract out the reactants. So the standard enthalpy change for this reaction, RXN reaction, is equal to the enthalpy of formation of the product, sodium carbonate, plus the enthalpy of formation of water, plus the enthalpy of formation of CO2, minus 2 times the enthalpy of formation of the sodium hydrogen carbonate. So that's sort of the process of what we're going to do without the numbers. Now we can go ahead and put the numbers in. So my standard enthalpy change for this reaction is equal to 1 mole of sodium carbonate times negative 1131 kilojoules per mole, adding in the reactants, plus 1 mole of water times negative 285.9 kilojoules per mole, plus 1 mole of CO2 times negative 393.5 kilojoules per mole. So that's all my products added in. Now I subtract the reactants. Minus 2 moles times negative 947.7, I kind of ran out of room there, kilojoules per mole. So now I go ahead and multiply through, and my standard enthalpy change for the reaction is negative 1131 kilojoules. You see the moles drop out, plus a negative 285.9 kilojoules, plus a negative 393.5 kilojoules, minus a negative 1895.4 kilojoules. So I think you can see that the most common mistake that's easy to make is to slip a sign as you're adding and subtracting positive, negative numbers. And we get delta H0 for the reaction is equal to 85 kilojoules. Because we have negative 1131 minus 285.9 minus 393.5 plus 1895.4. No, it's not going to help. I ran off the paper. That's 1895.4. So you're seeing the full page. Okay, so why did I stop in the ones place? Because I follow the rules for addition for sig figs, and I stop in the ones place here. Even though all these numbers have lots of sig figs, I can only report 2 in my answer stopping in the ones place. So products minus reactants, we just add them all up. I always just write it in one thing, product, 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 add them in, minus reactants. If you like to add all the products and then add all the reactants and subtract, that's fine too. Just watch the sign. It's easy to make a sign mistake. Okay, go ahead and do the next one with your groups on your boards.